Welcome, folks. It's Mr. Brewer. So we're going to take a quick look at a little tutorial here on how to classify types of matter. Sometimes as teachers, this is an idea that we think ought to be simple, but kind of believe that sometimes it's just lack of experience that causes some challenges with it. So let's take a look at kind of an organizer first, and then we'll apply this to some actual concepts, some objects that I have here to relate to. So when we talk about types of matter, there's generally two types. Some things called substances. Those would be what we would call our pure forms of matter. Pure generally means they're made of one kind of particle, either one kind of particle called atoms, in which case all the atoms would be identical, or one kind of particle called molecule, in which case all the molecules would be identical. So molecules kind of come in two forms. Molecules are either atoms of the same element joined up to make a molecule, or atoms of different elements joined up to make a molecule. So both of these happen to be forms of molecules. So anytime that the particles that we're looking at are pure, we'd be looking at a collection of all of the same atoms or all of the same molecules. So let's pause the video here for just a second so I can cue up my document camera. We can take a look at this from maybe a little more visual perspective. And so what we're looking at here is we're looking at a collection of particles, and we want to think about whether or not these particles represent something that's pure. Well, really all we look for is, do we see the same atoms every time that we see the particles, or do we see the same molecules in each case? So this is really only made up of atoms, because atoms are simply individual units. So we see 6 different atoms represented by these red cubes here. So it appears to me that this is something that's pure. It's the same atom every time we see it. It's not a mixed form of matter. If we were to take a look at what a mixed form of matter might look like, I know I have one here somewhere. So I should have one here that represents a mixed form of matter. Here we go. This mixed form of matter is represented by different types of atoms. So if we were to take a look at this guy here, right, we see there's 2 different types of atoms, hence we call it mixed. It's not the same particle each time we see it. So either the molecules that we see or the atoms that we see have to be identical in each case. So we're looking at something that we would consider a mixed form of matter versus a pure form of matter. Now these would be our pure form of what we would call elements, because elements do not have other kinds of atoms bonded to them. They're either single units, or elements are atoms of the same element bonded together. For example, also an element, atoms of the same element bonded together. We spoke about in class, there are 7 elements. I like to call them the genuine elements: oxygen, hydrogen, nitrogen, chlorine, fluorine, bromine, iodine. I know they're not all pronounced like that. It's just easier to say like that. So as a result, these particles represent something that is diatomic, one of the genuine elements. So again, something that is pure. Pure in molecule form, pure in atom form. So elements in the pure elements are substances. They're what we would call pure forms of chemical matter. There's another pure form of chemical matter where 2 or more atoms of different elements bond together. And these we call compounds. So what makes these compounds is the very specific ratio of the bonding. One dark colored and one light colored. In every case, the molecule that is represented is identical. There's a 1-to-1 ratio, and that 1-to-1 ratio reveals this is something that's pure again. So it's not an element, it's a compound. So every molecule that we see here is the same. Another example of molecules, something that is pure, right? Every molecule is the same. In this case, there is a 2-to-1 ratio, but the molecules are identical in every case. So here we're looking at the other pure form of chemical called the compound. So a compound, right? Different elements bonded together create a compound. Same element bonded together, right, creates an element still. So in any case, we're looking at the pure forms of matter right now. So our pure forms of matter, our two options are our elements and our compounds. So that covers the left side of this organizer, where we have what we call our substances. Our elements and our compounds are pure forms of matter, where the particles that we are considering are identical pretty much in every way. Not necessarily in every way as we get deeper and deeper into chemistry, but that's a topic for another time. So what we need to look at now would be, okay, what are the possibilities for our mixed forms of matter? So let's take a look at that from a visual perspective, if we could actually see the particles. And here we are, we're looking at a form of particles that are not identical. So we've got various different molecules here, this orange and dark colored combination, the red and dark colored combination, the individual green atoms, the blue one, the orange one, the kind of brownish one. So we got a collection of different types of particles together. They're not all the same molecule. They're not all the same atom. This makes this a mixed form of matter. And interesting enough, this explains kind of what we see with the naked eye. So what we can what we can tell with our senses relates to how particles are arranged. So maybe this representation with the naked eye might look similar to like what this crayon has done. I've melted a number of different color crayons together, and we can tell very clearly that the particles are arranged in a very non-uniform way, because we can see all these different phases, a phase that's red, a phase that's orange, a phase that is yellow. And phases just kind of indicate that there are different substances blended together here. So as we look, this would be what we would call heterogeneous arranged. It's a very non-uniform arrangement of the actual particles, and the naked eye tells us that. So non-uniform, meaning there's no physical kind of repeating pattern that is very orderly or organized. So as a result, we call this a heterogeneous form of matter. We could see another example where maybe there are kind of like two sides, heterogeneous arranged, right? The left side has kind of red atoms. The right side has molecules of orange and black kind of arranged. So what we see here is we see kind of layered arrangement, a left side that looks very different than the right side. Again, that would be heterogeneous, non-uniformly distributed particles, not evenly distributed throughout. Counter to that, homogeneous mixing, we would get some uniformity in terms of our mixing, almost like an alternating style pattern. And the uniformity affects what we see with the naked eye. So different particles distributed in a nice uniform fashion, we would call that homogeneous mixing. And maybe that might represent something similar to what particles do for liquid hand soap. I put some liquid hand soap in here. If we can ignore the actual air bubbles trapped in it, we kind of see that it looks the same throughout. And it looks the same throughout because it's been blended together in such a vigorous way that the particles kind of stay in their nice uniform arrangement. So this nice uniform arrangement tells us these are blended in a pattern that we would call homogeneous mixed. So homogeneous mix versus heterogeneous mix, just they have something in common. They're each made of multiple types of particles, right? This is two different types of atoms, right? This is different types of particles. There's molecules and atoms in here of all different types, but they're blended together in a non-uniform way when we call it heterogeneous. They're blended together in a rather uniform or a nice even distribution when we call it homogeneous. So that sort of wraps up what I wanted to cover from the visual perspective of thinking about particles. Now let us take a look at this from another angle where we're kind of just using words to make a description. Okay, so here we are. So the goal is to classify all these different materials. We probably won't do all of them, but I'll give you a sense for how it works. So we want to classify all these different materials into either substance or mixture. Are they pure forms or some mixed forms of matter? If we choose substance, we should say element or compound. If we choose mixture, we should specify homogeneous or heterogeneous. So here is, I think, a good place to start. We kind of go through almost like it's a flow chart. So the flow chart kind of starts like this. Is the chemical that we're interested in, or the material, is it found on the periodic table? So that's where we'll start. We'll start with tin. Well, tin is found on the periodic table. So since we know tin is found on the periodic table, we're going to call that pure, right? Substances are found on the periodic table. It's called the periodic table of elements. So since it's called the periodic table of elements, right, we know that it's a pure form of matter. So what we need to do then is we need to say, okay, well, since we realize it's on the periodic table, right, we're going to come over here and we're then going to fill in, let's clear that. We're going to fill in the idea that we know this is an element. So I'll just put an E for element. You know what? Let's just write it in, element. So if it's found on the periodic table, we call it an element. It's a pure form of matter called a substance. So that's kind of the starting point. So let's progress a little further. Glass. Now we know glass is not found on the periodic table. So the next thing we go to is, does it have an exact formula for its composition, for what it's made of? And if it did, I would have provided it here. Because of limited experience, we don't really know a lot of chemical formulas as learners yet. As our time progresses and experience begins to build a little, we might get a little more in tune with what chemical formulas are sort of about. So if we know it's not on the periodic table and it doesn't have a well-defined chemical formula, we know it's a mix. We know it's some mixed form of matter. Then what we want to think about is, how might it appear if we saw it in front of us? Usually when glass is manufactured, they would like the glass itself to look very uniform. So if you shattered the glass, one piece of glass, other than if we ignored the shape, would look very much like any other piece. So we know that that has to be blended kind of homogeneous in order for that to happen. So glass is typically homogeneous blended. It's sort of the same throughout in terms of the way the particles are distributed. So there's the starting point. The starting point goes from, is it an element? If the answer to that is no, we go to, does it have a well-defined chemical formula? If the answer to that is no, we know we automatically have a mixture. And then we think about what the particle distribution might be like. Are they evenly distributed? Are they randomly distributed? And that kind of leads us to homogeneous or heterogeneous. So we think about sand. Sand we know is not on the periodic table. We also know that I didn't give you a chemical formula for it, so there's no well-defined formula. As a matter of fact, sand on different beaches looks different. You go to some places of the world, sand can be black. Other places it could be white. Near us, the Jersey Shore, the beaches tend to have sand that is kind of a tan to whitish color. So we know sand has a composition that varies. It has no well-defined formula. We're going to call sand a mixture. As a matter of fact, if we took one handful of sand from each side of our beach towel and looked at them, they would still look very different. So we know the arrangement or the distribution of the particles in sand tends to be rather heterogeneous. It's randomly arranged, not uniformly arranged. So we'll call that heterogeneous. Okay, so let's try the criteria again. Nitrogen, aha! on the periodic table. We'll call that a substance, right? And we recall that the periodic table is called the periodic table of elements. So since it's called the periodic table of elements, we're going to call nitrogen an element. It's one of the pure forms of matter. Okay. So let's get down to an example now. Oh, look at this. Carbon monoxide. That's two words, right? All of the chemical elements are named with one word. And then the deciding factor here is it tells us there's a ratio, a fixed ratio of 1 carbon to 1 oxygen. There's a well-defined formula for this. So here's something that's not on the periodic table, excuse me, but it has a well-defined formula. That makes it a substance again. It's pure. It's always defined by a 1-to-1 ratio of carbon to oxygen, but now we call that a compound. Compounds have well-defined formulas that are constant. They're fixed. Like water would be H2O, carbon monoxide would be CO. So that's the way that this works. We have the same sort of thing for glucose. So again, right, we would write substance. It has its well-defined formula. It is a compound. I wrote a little note here at the bottom because there are a couple of, confusing examples. These things that are called alloys, metals that you know that exist, but they're not on the periodic table, for the most part, are pretty much called alloys. And alloys are usually homogeneous mixtures of various metals blended together. So brass, we know brass isn't on the periodic table. You'll never find it on there. So we know that that would be called an alloy, some homogeneous mixture of various metals. Usually brass is copper and zinc mixed together in various compositions. So anytime that we know that there's a metal that exists like steel, bronze, sterling silver, 14 karat gold, but we realize it's not on the periodic table, we can say, aha, that's a mixture, it's homogeneous, it's that special kind of homogeneous mixture called an alloy. So we'll look at one more example. Let's look at chocolate. Aren't there different kinds of chocolate? There's white chocolate, dark chocolate, milk chocolate. That means there's no exact composition, no chemical formula for chocolate like there is for glucose or carbon monoxide, guaranteed to be a mixture. You also knew that chocolate wasn't on the periodic table, right? You didn't need me to tell you that. So usually when they make chocolate, they like to uniformly mix the particles together so that one bite tastes exactly like the next. So we would call that homogeneous mixed. So that's a little lesson on how to classify states of matter into the various classifications. So the various classifications, come back down to, just a moment. Come back down to, that there's two major categories. The substances, the pure things, which we call elements or compounds, right? It depends on what type of substance. And the mixtures, right? Which we call homogeneous or heterogeneous, which depends upon how those particles are arranged. So for now, I'm going to leave you with this. I'd ask that you learn to try to respect your chemistry, but don't fear it, folks. We can learn this stuff. Until the next time, this is Mr. Brewer. Have a great day.